Hello everyone, welcome to today's video on combining like terms to create equivalent expressions. So there's a lot of vocabulary in there that's important, so we're going to start there and then talk about how do you combine like terms in order to create equivalent expressions, and then we'll see two examples and one you try. So our first vocabulary word is term. So when we're trying to combine like terms, first we need to understand what a term is in a math context. So a term is either a single constant, like a number, or a variable. So x, 2, those are both terms. Or they could be the product of numbers and variables. Product means to multiply, so like 2x, 2 times x. And they are separated by addition or subtraction signs. So if we see here in this example, we have that 5x plus 7, we have two terms there. We have 5x, that's one term. It's an example of a product of the number 5 and the variable x, as well as our second term, which is the constant 7. And they are separated by that addition sign, so we have two different terms. So like terms are terms that contain the same variable raised to the same exponent. And then all constants are also like terms, so just any plain numbers. We can think of those as variables raised to a 0 power, which isn't super important, but it's the reason that the general definition terms that have the same variable raised to the same power includes constants. Okay, so that would mean like 2x and 4x. Those are like terms. 7y to the power of 2 and 8y to the power of 2. Those are like terms. But if we have a different variable or a different exponent, they are not like terms. Okay? All right, so then we want to combine these like terms. Combining really just means adding together. So we're trying to create equivalent expressions. These are expressions that have the same value for any value for a variable and have the same simplest form. So for example, 1 plus 1, okay, that's a mathematical expression. And then the expression 2 has the same value as 1 plus 1. So these are equivalent expressions. And they'll have the same simplest form. The simplest form of both is 2. Another expression that's equivalent to these is 3 minus 1, right? That again has the value of 2. Okay, and we can do the same thing with variables. So maybe instead of thinking about like 1 here, we think about 1x. So 1x plus 1x, that's equivalent to 2x, and it's also equivalent to 3x minus 1x or minus x. So we'll see more of that. But the idea is that when you simplify all of these, all the expressions, you have the same form. And if you were to substitute in any value for my variable x here, so let's say I let x be 5. What I get up here is going to be the same as what I get here and here, because those are all equivalent to each other. How do we simplify equivalent expressions? By combining like terms. So if necessary, if we see parentheses such that we need to distribute, we should always do that first. So step number 1, we want to apply the distributive property if we need to, if it applies. For step 2, we're going to rewrite all subtraction as the equivalent addition. Subtraction is the same as adding the opposite. So subtracting positive 3 is the same thing as adding negative 3. And subtracting negative 3 is the same thing as adding positive 3. And then for step 3, we're going to annotate the like terms. So let's say we're going to circle all the constant terms, all the just plain numbers. Then we're going to box in all the x terms, and then maybe we have y terms too, and we're going to underline all of those, just so we're clear about what we have. And then we're going to rewrite the expression so that the like terms are all next to each other. Okay, and what we're doing there is we're applying the commutative property of addition. The commutative property of addition says that a plus b is equal to b plus a. In other words, you can mix the order. 2 plus 3 is equal to 3 plus 2. So we know we're able to move this order around. If you think about the word commute, like what's someone's commute to work, it's like how long does it take them to get to or move to work. So it's about this like moving around idea. Okay, so we're going to move them all around. So we have all the like terms next to each other. So we have like all the x's here and all the constants here, for example. Then step 5, we're going to add the coefficients of the like variable terms and keep the variable. So when we have the variable terms, we add the coefficients, which is the number outside next to their variable, and then we keep the variable. That's how we're going to combine those like terms. And then we'll add any constant terms we have together. And once we've done that, we will have simplified the expression. So let's look at example 1. Simplify 5x plus negative 4 minus 6x plus 2x minus 3 plus 8x to the power of 2. Okay, so like always, I'm going to rewrite it. Now that I rewrote it, let me go back to my steps. What am I going to do first? Well, first it says, if applicable, apply the distributive property. But I don't have any parentheses in here, so I don't need to distribute anything. Okay, so I'm going to move on to step 2, which is rewriting all subtraction as the equivalent addition. This is just going to make it much easier when we're going to combine it, and it's going to make us not make mistakes. So let's just go step by step here. We have 5x plus negative 4. Okay, that's already addition, so we're good. We don't need to change anything. But then we have minus 6x. So currently we are subtracting positive 6x. Subtracting is the same as adding the opposite, so we can rewrite this as adding the opposite of positive 6x. The opposite of positive 6x is just negative 6x. The x doesn't really change it. Just think about what's the opposite of positive 6. Okay, then we have plus 2x. That's already addition, so we're happy. Then we have minus 3. We want to rewrite this as addition. So we can rewrite subtracting 3 as adding the opposite of positive 3, which is negative 3. And then finally we have plus 8x squared, or to the power of 2. Now what we want to do is we want to annotate the like terms. So I have 5x. So 5x, what are other like terms? So that's going to be other terms that contain the same variable raised to the same exponent. Okay, so x is just raised to the exponent of 1 currently, or you could say it has like no exponent. Okay, so we have negative 6x. That is another term with an x, and then we have positive 2x. So those are all like terms. Now, what about 8x to the power of 2? Is that a like term? No, this is going to be all by itself. This is going to be something different. This is not a like term with 5x or the other blue terms because it's raised to the power of 2. It's not raised to the power of 1 or doesn't have like no exponent. And then lastly, let's annotate our constant terms. So I have a negative 4 and a negative 3. So I've annotated my terms. Now what I want to do is I'm going to use the commutative property to rewrite the expression so the like terms are all next to each other. Then we're going to have my x terms, 5x plus negative 6x plus 2x, and then I have plus negative 4 plus negative 3. Alright, and then finally I just need to simplify by adding the coefficients of the like variable terms together and then keeping the variable and adding the constants. Okay, so there is no like term with this 8x to the power of 2 or squared, so I just get to leave that as is. Now for 5x plus negative 6x plus 2x, I just need to focus on these coefficients. I need to do 5 plus negative 6 plus 2, positive 1. So I get 1x. I added the coefficients, 5 plus negative 6 plus 2, then I kept my variable x. Alright, and then finally, I'm going to add the constant terms together. Negative 4 plus negative 3, I have the same sign, they're both negative, so I add the absolute values and keep the sign. 4 plus 3 is 7, so I get negative 7. Alright, so this would totally be a correct answer. This is simplified. I have combined the like terms. You might see it expressed slightly differently, so I'll just do that as well. When we have 1x, we know 1x is the same thing as x, because multiplying any number by 1 doesn't change it. And then I'm definitely totally good to write plus negative 7, but I could also see this as minus 7, because we know that addition and subtraction, how they're related. Subtracting positive 7 is the same thing as adding negative 7. So again, it takes a lot of work, but if we go step by step, we're going to be in great shape. So let's try one more together. So we have negative 3 times the quantity y minus 4 plus 5 plus 3y. Okay, here if we look at step number 1, we know step number 1 is to apply the distributive property if it's applicable. It is here because we have this quantity in parentheses, and then a coefficient, that -3 that's being multiplied to the entire quantity. Thus, we're going to distribute first. Okay, when we distribute, I normally have us rewrite subtraction as addition. I can rewrite this as y plus -4 plus 5 plus 3y, and then I'm going to do -3 times y plus -3 times -4. Okay, so -3 times y is just -3y, and then I have -3 times -4. I have both negative numbers, they have the same sign. Remember, when we're multiplying, if you have the same sign, you get a positive product. So you just get positive 12 here. And then we're going to pull down everything else. Plus 5 plus 3y. All right, so now at this point, we just need to annotate the like terms and then combine them by adding them together. So I will start here with my -3y, the variable y, not raised to any exponent or raised to the exponent of 1. So what are my other y terms? I have this y term, 3y. Okay, then from my constants, I have 12 plus 5. Notice that this was all addition. So then we're going to rewrite this using the commutative property of addition, where our variable terms are together and our constant terms are together. So -3y plus 3y, we're going to add those coefficients. So what is -3 plus 3? 0. -3 plus 3 is 0 because those are opposites, and opposites always sum to 0. So that means that I could write here 0y because I add the coefficients and then I keep the variable. All right, and then 12 plus 5 is 17. We wouldn't really say this is fully simplified because 0 times y is something special. So what is 0 times 2? 0. 0 times 100? 0. 0 times any number is equal to 0. So 0 times y is also equal to 0. And so I really have 0 plus 17. I changed colors because now we're just dealing with a number. Now it's just a constant. And what's 0 plus 17? It's 17. So it's kind of hard to believe, but this whole expression that we started with, -3 times y minus 4 plus 5 plus 3y, is equal to 17. So we simplified this expression by combining the like terms and distributing to get a much more simple expression that is still equivalent to the initial one. Right? Awesome. So now it's your turn. We have 4 times -2x minus 5 plus 12 minus 4x. Remember here when we're distributing that it might help us to rewrite that -5 using addition. So we're adding a -5 and then distribute and go from there. Combine the like terms. All right, give it your best shot. All right, and you should get -12x minus 8 or -12x plus -8 because those are equivalent to each other, and they're about like equally simplified. Okay, so what do we do here? First thing we need to do is you need to distribute, right? And again, I mentioned when we distribute, it's always good also to take care of any subtraction and rewrite it as addition so we don't make sign errors. So subtracting 5 is the same thing as adding -5. So that was like my first step. Then I'm distributing my 4 to my 2 terms. 4 times -2x is -8x because 4 times -2 is -8. And then 4 times -5 is -20. So now I have the equivalent expression -8x plus -20 and then plus 12 minus 4x, just pulled down from my original expression. Then I have this minus 4x. I want to rewrite that as addition so I don't make sign issues or errors. So subtracting positive 4x is the same thing as adding -4x. So that's what I did in this line, and now I'm good. I have all addition signs, 4 different terms, and I want to combine them, simplify to actually it's going to end up being my 2 terms. Okay, I annotate my like terms. -8x and -4x are like terms because they both have the variable x raised to no power or the power of 1. And then I have my constant terms, -20 and positive 12. Okay, I use the commutative property to write those next to each other. Then I do the correct addition, and I get -12x plus -8. Awesome. Great job, everyone.